You have it?
No, I have my phone.
No, she has the keys.
Yeah, I kind of heard it too. I know that Eiffel Tower sound.
Yeah.
Thank you.
Can you do this?
Ja, you can read it.
Just think it.
Boring.
No, it's EXE.
That's so boring stuff. It bores me.
You can change it.
It's good, but
Your phone?
Right. It's a triple now.
But there's one each side.
Bear in mind we had it. I know.
Oh, yeah.
Wait till it I don't know.
Julie noted.
I think this is
Right, we'll start with physics. We'll do the homework questions first on Young's modulus, and then we'll talk a little bit about some maths required for the assignment. What's wrong? Homework giving you a hard time?
No.
We're good. Oh, cool. Right. Let's open up the questions then. Materials, Young's modulus, and let's open up the questions. Today, I'm getting carpet.
Getting what?
Carpet.
what's the topic?
Carpet.
It's summer now, stop it can wait. Oh yeah, it's summer now, then it started raining.
What?
It was raining outside.
Yeah,
Yeah.
it's summer. What do you expect? It was hailstones, yeah. Okay. We didn't do any of these, did we? No, we didn't do any of these. Right. Did anyone try them?
Yeah.
Anyone try them in the real world, not dreaming, on actual paper? Is that a no?
Do parallel universes count?
They do not.
Did the homework write you?
What?
Then, was that like the creator's homework?
No. The homework created you in the parallel universe.
And it wrote you down.
Yes. Yeah.
It's a parallel universe, exactly, that's what happened over there.
Clearly you need to brush up on your CC multi-universe.
Oh, I am up to date.
Are you?
I was expecting something later.
Are you? Did you know there's a universe out there where like Batman's a pirate?
Yes.
You know this?
Yes.
Good.
What?
There's a banana kills you.
Where Batman is the Joker.
Oh, that's so boring.
No,
that's
not.
That's so predictable.
His mother or his father is Batman.
Is this Crisis on Two Earths?
I don't know.
I opened YouTube and I searched for the movie. It's almost about the circle and
Flatline, yeah. And you watch it?
Boring. I stopped after 3 minutes.
You could not appreciate such
It's a 15-minute thingy. I stopped after the first minute.
50 minutes?
Yeah, it's a long
That doesn't
movie.
sound like the movie, because the one I saw was like a 90-minute movie.
Yeah.
Then, yeah, it was a long one. It was like 3 minutes, that's enough for me. But like it was the same story. The square or the hexagon and the sun, and then they explore other places.
I'm sure someone in this class would like it. Not everyone is like you. That is a good thing, or a bad thing, I don't know which. Okay. Since you didn't do these...
Would you want more students like me in your class?
No.
Then that's it.
Yes. I promise you one is more than enough. More than enough. In fact, I might even say one is too much, but I won't. Okay. We'll do these now. We'll take turns, I think. The first one and two are very, very easy and quick, okay? So the first one, we have a 1 meter rubber wire. It's hung from a table. How thick is it if 100 grams cause it to extend a distance of 1 centimeter? You need to use the table for Young's modulus. She wasn't here yesterday, remember? So if you're looking... Were you? I thought you left.
No.
Oh, you had the table. Very good. Oh, of course, because you were looking for the Young's modulus questions. Yes, yes, I understand. Okay, number one, please, and we'll take turns. Faisal, please use actual paper to write on, not to eat, to prevent any confusion.
What's the question to ask him?
How thick?
No,
Thickness.
question 2.
Oh,
How much?
yeah, the distance, the x.
X.
Contract means this. Expand, contract. Expand, contract.
Look at your answer and then look at mine and tell me I did the same.
You can't look at what's not there.
Oh,
Who
what
has...
did I teach you today with one link?
What students have the answers now?
We did the experiment today with Mr. Steven.
Center of gravity experiment.
Yeah, we did it with this folder that had this best of and we used my chain as the...
Oh, he actually did it. Good for him. He came into the office 1 minute before the class started and said, what am I doing in the SAP? I'm like, when is it? He's like, yeah, in 1 minute. He said, I emailed you yesterday asking what to do. And I said, I didn't get an email. Then he checked his email and he said he wrote the email, but he didn't actually send it. Stephen Bruce! So I'm glad the class actually went ahead. Okay, do you have the first answer now, Andrew? Good. Yusuf? Okay, so what am I looking for in this? I'm looking for how thick it is. So in the formula, number 1, we have Young's modulus is stress over strain, which is force over area, extension over natural length. It's really the area that's the unknown here, because what's the force here? It's the weight. So that's weight over area, extension over length. Okay, so I'll just clean that up a little bit. That's weight over extension times length over area. A bit more cleaning up. Area equals weight times length over extension times Young's modulus. What did I say? That was 100 grams? So that's 0.1 times 9.81, so that's 0.981. And what was the length? A meter probably. Yeah, and the extension was 1 centimeter. And then what's Young's modulus?
0.1 times 10 to the 9.
So that's divided by 1,000, isn't it? No, that's divided by 100. So 98.1 times 10 to the minus 9? No, 981. Dudes, help. Multiply by 10, multiply by 10, multiply by 100. 1, 2, 3, 1, 2, 3. Sorry. 981 times 10 to the minus 9? That's pi r squared, of course. So what I need to do now is take this answer divided by pi and square rooted and times 2 because we want the thickness. So what is the thickness then in the end? Times this answer by 2. What's wrong, Andrew? You look distressed.
I got a different answer and from yours, and the calculator has a different answer from mine and yours.
Beautiful. Beautiful. Well, actually, I've got a calculator here. That's beautiful. Right, let's see. Square root 98. Huh? Oh, well, that's because I was doing stuff in my head. I might not have it in the most simplified, elegant of forms. And then multiplied by 2. What answer did you get in the end? Your final answer?
1.117 and stuff to the company. So 1.1.
Milli. 1.12 millimeters. Did you get this answer, Lee?
The question is how much
How thick?
thick.
Not round. Thick.
Thick is
No. This straight line.
yes,
Yeah.
Thick. From here to here.
Unhappy?
the difference like this is
Yes.
thick.
Yeah.
This is thick.
No.
Yeah.
No.
Yes.
No.
It's different
Hang
than
on.
the
Yeah.
perspective.
Yeah, context. So obviously, if you're talking with the phone, you must mean what you had at first.
Yeah.
Yeah.
But it's not impossible for it to be the other way. It depends on the context.
But in this context, the wire is always.
Yes, yeah. And I cannot think of a context for a wire where it's not that. That is that. Although,
Not for this example.
no. Yes.
They want to ask us how thick is the wire and want the length of the.
You could ask, if I said how thick is a coin,
Yeah, you did say this once. It was like, huh?
yeah, the coin. It depends how you're using the coin.
It's also the electricity one.
Yeah.
You use it as a.
Yeah. Okay, number 2. A 2-meter glass cylinder of radius 3 centimeters has a 1 kilogram mass placed on the top of it. How much is the glass contract by?
What's half kx squared?
That's like the energy required to the work done.
Yeah.
What is the question of number two?
Question 2? Oh, 3. I want the X. No, I give you the A because I tell you they're 2 centimeters thick.
What's the question?
What's the X? Extend. Like expand. Same.
Strong? Yes, we'll check.
You're finished, Yusuf?
Yes.
And Juan?
Yes.
And you get the same answer? Of course, doesn't mean you're right.
No, it doesn't mean
What did you do?
1.91 is 1.2.
Yeah.
Minus 8.
Oh.
It's just understood by the 6.
Oh, I hate minus
No, he did. No, he very clearly said minus 6.
8.
Yeah, it's 8.
8.
It's minus 6.
We shall see. Okay. So what are you told in this question? You have glass. What did I say the height of the glass was?
2 meters.
And what else did I give you about the glass? Did I give you the thickness or the radius? I gave you the radius. Okay. So that's 3 centimeters. And then I put a weight here, yeah? 1 kg. Right, so what did I want? The contraction, was it? So Young's modulus is stress over strain. And I'm looking for the x, isn't it? So I get Young's modulus equals F over X L over A. So X equals FL over YA. What type of force is this though? Weight, which is mg. What's the weight? It's 1, isn't it? And the g is 9.81. And the L?
2.
So what's that, 19.62? And what's the Young's modulus for glass? What is it?
17 times
10
10,000.
to the 9. And the area is pi 0.03 squared. So, we'll see. Now look at that face. He's going, yeah, I got this. Those guys are going to look so stupid now.
No. I think I found the
Oh, that's the face of...
I think it could be, I don't. Maybe I think it
We'll see now.
Yeah, I wrote 7
I'm going to put my answer in nanos. 99 nanometers. Tough break, Yusuf. Maybe there's a parallel universe out there where you got it right.
We have the answer or something.
Well, the answer got Yusuf right, yeah. Okay, on to number 3. So number 3, steel wires support a lift. The lift has a mass of 1500 kg and the wires are 2 centimeters thick, although I think in real life they're thicker than this. And there are 4 wires, and I want to know how much the wires extend by if 2 60 kg people enter the lift. You understand? So again, I'm looking for the X. Like in the last question. What is tricky about this question is the mass. Do I need it? Is it relevant? Right, so, you know there's a plug right beside you.
Doesn't go in, I tried it. Yeah, I'm not that
Busted.
sure.
Just thought I'd ask.
This is an actual material that's on the...
I would think I would have given you steel.
So it's steel.
Steel wires support the lift.
Steel wires support the lift.
Oh, I was reading the fourth question.
Ah, well that's why you're not making any progress. Because the fourth question says an unknown material. The unknown material supports the lift. Nah, builders like to know what materials they're using for their lifts. It's a safety thing, you know. There's lots of looking and thinking, but not much doing and action.
The mass of the lift doesn't make a difference.
Well, that's what I want you to decide. I'll do it in a moment.
No, it won't.
Well, it makes a difference, but does it make a difference for what we're looking for?
No, that's not whatsoever.
But obviously it makes a difference because the steel wires certainly feel a difference. Okay, you all are looking pretty confused. No, you feel like the answer's inside you?
I can't answer.
You are the answer, then what is the question?
Let's figure out.
Let's see, what could the question be that makes twice the answer? Who is the person that drains Stephen the most of energy?
Pretty sure.
Are you pretty sure? Are you pretty sure? Who else could it be now?
You know Stephen better than I do.
Yeah, no, I have a good relationship with him. I know him pretty well. Which student has been living off of nothing but bars from Tesco for the last 2 weeks? That is the question. You're the answer.
Today morning I found out
Yes.
that there is a shop in Australia
Yes.
with the same offer, and my friend bought that.
But they give you 10 bars and each packet has 2 bars in it.
No. Yeah.
No, they give you 10, like, there are 5 packets.
Yeah.
I thought they had 10 packets, and then I said I'm running will be spent in like 2 days, 3 days.
Have you just been eating these? Like, is this your diet right now?
No, I have a really excellent host family. They cook me good food.
Oh, good. You don't have to live off of granola bars.
No.
Guys, do we have an answer yet? You think you got it, Wong? Maybe.
You're not
Wong! Omar! Are you doing this? I hope so. Faisal? You know what to do for this one? Please. I could order you. I could command it. You think you got it? Believable. Put it in micrometers.
I have the same answer as Lee.
I have the same answer as my son.
Do you use? And what's that? No answer?
No.
What answer did you get?
5.886 or something like
I have an answer as well.
1, 3, 2, 2, 4, 3, 2, 4,
What did you get?
You even need the thickness, and you need to know weight, yeah. Yeah, now I have a new one.
Do you? Great. I love these physics problems that update live. The answer keeps changing. You never know what's going to happen next. So what's your answer now?
1.5 times 10 to the 7.
Okay, what answer was yours?
2.5 and 10 to the minus
Has anybody gotten the same answer as anyone else yet? One?
Yeah.
What's your answer?
29 cents.
Six.
10 to the power negative 9.
Yeah, that's what I meant. So, right, let's have a look. So, I hope you figured out that the mass of the lift is not relevant because the lift is already hanging from the wires to begin with in the story.
You did that?
You mean to say we did that?
Yeah, I'm disappointed.
So the mass of the lift is not important because it's already hanging from the lift, so it's already extended by the lift. My question is the further extension caused by the extra weight. So it is only the extra weight that you need to consider. Right. And also, we know what the length of the wires are. They're 1 meter because I said per meter. I'm getting there. So Young's modulus is stress over strain. So Young's modulus is force, which is weight, over area, extension, which I want, over length. So that means X equals W over X L over A. I'm sorry, that's Young's modulus. So then that means X equals the weight times L over Young's modulus times A. What's the weight? 260 kg, people, isn't it? So that's 120, 9.81 times 1 over, and what's it for steel, please?
It's copper.
Oh, I thought it was steel.
Steel, what's steel?
It's, what is steel actually? It's a mixture of...
Brass and
Iron.
I thought it's copper.
No, steel.
No, I think it's way stronger than this steel and copper. I think it has iron.
Yes, it is iron and carbon, yeah.
Not carbon.
Oh, what?
No, you might be right because it goes through a coking process.
Yeah. Yeah, I remember, yeah. The process of making steel.
Anyways, no matter.
It's an alloy of iron and other elements. Primary.
Yeah.
Primary.
Yeah, go on.
Yeah.
That's why the function.
You know, Faisal, it would have been a lot easier just to say Yusuf was right.
Yeah, he was.
Okay, steel is a mixture of iron and carbon
And other.
and other things. There it is.
See?
You spelled it wrong there. 200 times 10 to the 9. And the area is 4, and what's the thickness?
0.0000.
I think you have too many zeros there. Is the thickness 2 or the radius 2? Yeah, so the radius is 1. Okay, what's this please, if you can type it in? 120 times 9.81 divided by 200 times 10 power 9. You have it wrong? Thank you.
Yeah.
14.7 micrometers.
really close.
What? What did you get? 14.7 kilometers.
No, 1.5 times something, plus minus 9.
Yeah, how is that close? It's off by a factor
No,
of like
but
1,000.
I have like 1 point... I have 147.
Okay. But let me just put it this way, your bank balance is quite different if it's 147,000 or if it's €1.47.
Yes, but the thing is, I didn't do all of that. I just used F equals KX. Why can't we do that?
Do you have the K?
Yes.
Do you?
What is it?
You don't have nothing.
Wait, when you're writing in
Oh, no.
over one.
Because it's 2 centimeters thick, so the radius is 1 centimeter. At least he's doing it, Faisal.
Yeah, I didn't say anything.
I used y equals L over 8 and 11.
10?
It's like a derived formula from...
No, don't be using that. Okay, next. Where?
Oh.
Did you type this in?
Yeah.
And?
Just let him slip like that, Mr. Steven?
Bet €1 million.
I didn't this time.
Is it times 10?
I...
4.7.
Wow, guys.
4.7?
Not here. Not here.
Yeah, that's what I had.
14.
You say 14.
Did I? Oh,
Yes.
a simple mistake. Okay, next one. Right, now, Yusuf, the unknown material. So, an unknown material is used for hanging a weight. When the weight is 1 kg, it extends by 1 millimeter, and when it's 1.5 kg, it extends by 2 millimeters. What is the value of Young's modulus for this material? The natural length is 1 meter, and the area is that.
Again, I go back to my same question. Material in the table. Is it one of the materials in the table?
What is?
The unknown material.
Haven't a clue.
You're supposed to find
Yeah,
Yeah.
'cause
In other
it would
words,
be like
find the Young's modulus. That's it.
now you know deep down in your engineering heart that is never going to be a weight stool problem. Don't you know that deep down? That's right. So you have to calculate Young's modulus. Faisal, please, you're draining the life out of me. Will you just do a question?
you guys have any good medicines next year?
For cold, I get Lemsip. It's like a lemon drink. It's a powder, you pour it into hot water and makes a lemon drink. It works pretty well, like a lot of people find it helpful. From the pharmacy, just Lemsip. They'll know what it is. It's sold everywhere.
You put it in hot water.
Yeah, yeah. It's good, isn't it?
When you have a sauce.
Yeah, yeah. Just mix it in with hot water like you make coffee and stir it and it will work.
How much, what's the quantity it makes? Like, is it like a small
It's like, yeah, like 1 packet for 1 cup, yeah, and it comes in like packs of 5 or something like that. So it's something like you can drink 3 of them a day or something, I don't know. So after 2 days, you know, you should be feeling better. It has some paracetamol in it, which is like a painkiller, so it'll help.
I guess how it works is my mom used to do the same thing with 3 lemons. She'd put them in boiling
But
water.
this one actually has paracetamol inside of it, like it's a medication too.
They're like Panadol.
Yeah, like Panadol. So if you have a fever or anything, it will reduce it. So it's a bit more potent than just lemons. It's lemon flavored though. Okay, how are we doing with number 4 here? We got an answer? We got a right answer?
Yeah.
Okay. So what do you know about this material? Well, let's look at it at a graph. Whoops. Here is, oh my goodness. That's better. This is extension in meters. And then here, this is, what did I say? Force, wasn't it? Force in newtons. Now, when the extension is, what's it, 1 millimeter? Is it 1 millimeter? Which means the force is 9.81. And then when it's 2 millimeters? What is it? 1.5, so it's 1.5 of these. Whatever, what's 1.5 times 9.81? 14 point... Do it myself. 14.715? Thanks, kids. 14.715. So, do you remember what the slope represents here? Okay. Young's modulus. Yeah. So Young's modulus is the slope. So the slope is 14.715 minus 9.81 over 0.002 minus 0.001, which is 4.905 over 0.001, which is 4905 pascals, which is 4.91 kilopascal. So the cross-sectional area was redundant information. I don't know why I told you the cross-sectional area. It was not necessary to calculate it. Maybe that's why I told you it. Did anybody get that?
Can we not solve it by stress over strain?
Yeah, maybe that's why I gave you the area, so you could do it that way. Cause
Can you do it that way? Because the answer is different.
is it?
Yeah.
How much do you get?
How much do you get?
Really?
What force did you use? What extension?
Here, let me have a look. Okay. So Young's modulus is stress over strain. So we'll go with the first one, which is force. And what's the force?
The weight.
The weight. And the first case is 1 kg, is it? So what's that? 9.81.
Yes. Over
The area, which I give you.
1.14
Yep.
times 10 power negative 4.
And then here is
Strain. The
Yeah.
extension over the length. 0.01 over 1.
I tell you natural
The
length is
original
1.
length is 1, yeah.
Do you know what I have a feeling happened here? I must have given you the wrong area if you don't get the same answer. Yeah, isn't that the area? Yeah.
Yeah. If you do this, you get 3.08. Something like that. What? No.
Yes, that's what yours.
No, bro.
What? Tell me wait!
Where am I going, bro?
Apart from waking up and being here today?
Yeah. Yes.
So what's your... Yeah, I know it's wrong. And the reason it's wrong is because in the question I gave the wrong area. That's my mistake. So I should delete the area from the question, which I will do right now.
But that's nicer to solve it this way. So just correct the area.
That is an interesting idea. I could do that, or
Delete the whole question.
delete the area.
Yeah, but I thought the
What?
graph of f and x, the gradient gives you the k. Because, like the formula, f equals kx.
What? No. 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 What? No
Thank you, Yusuf. Thank you. I apologise, because I believe that's what Omar, that's what you said at the beginning. It's the K. Oh, thank you for your honesty. Wong, you said it. So actually what I have here is not the Y, it's the K. That's why I needed to give you the area. Because you have a way to relate the area.
Yeah, because...
No, hang on, don't pretend like you know what's going on there.
Against strain, then you will get the...
Yeah. So I know this now, thank you. Right. I'm sorry.
You need the area now.
No, I think I can put the area in it. Now, listen, we have the K. Thank you, Wong and Yusuf. So we need to change the K into Y. Not really a long process, because I showed you how to do that in the last lesson. Do you remember you have F equals K delta X? And then you also have Young's modulus is stress over strain, which is force over area, and then extension over length. So we know the K. So we have K, I guess we could say, is equal to F over extension. And we're looking for Young's modulus. So if I take that and put it in here, I get Young's modulus is K times 1 over A, 1 over L, because we know the F over X is K. So the Young's modulus is L over A times K. Now what was the length? What was the natural length? 1. So all I need to do to finish this now is take this answer and divide it by the area, which was 3.14 times 10 to the minus 4. Okay, what do we get now? 15.6 megapascals. I just took a guess. If it wasn't, I would have tried something else.
But you just did it with stress over strain, you didn't get this answer. So why do we have a different answer?
Didn't I?
I think the case wrong. No, I think it's that one.
You think my case wrong?
Or just not find the case, use first over strain and get the answer directly.
Yeah, but you still have to use K.
No, you don't. You don't.
No, you don't.
K.
He's right.
Now you're even. So whatever you do, neither of you make a mistake to the rest of the class, because you're currently balanced, okay? You know what, I'm starting to think maybe deleting this question is a good idea, because there's something wrong in it. Then I'll have to replace it by something else.
Or in it.
What?
Doesn't have to be something wrong in the question, could be something wrong in it. This.
Could be. But I'm way too tired to figure out what it is. So I'm going to believe that there's something wrong in the question. So I'll delete it or I'll change it.
You know, leave a mark. And then next time you teach this lesson, see if your students figure it out or not. And then laugh at them.
Maybe. But I'm thinking maybe I'll delete it. But then there's only 4 questions. That makes me sad.
Okay. On the bright side, you're getting your carpet today.
Indeed, yes. Yes, that is the bright side of today. Alright, well, let's have a look at 5 now. 5 is like an example that I did.
A boy hand.
So we deleted that question?
Huh? This question, what question? It never existed. So there is no 4. There's only 1, 2, 3, 5. No, I know what I'll do.
Just rub the top.
No, I'll change it. I'll say, what is the value of K? Yeah. Then I don't need the area. Yeah. Problem solved.
So what is the value of K?
That was my very first answer I got.
But we think that is wrong.
Well, what's the unit?
No, we only thought it was wrong because it wasn't matching up with when we were using it to get Young's modulus.
So if we use Young's modulus, we'll be
But this
using
question
the-
doesn't have Young's modulus anymore.
We're
It
using
doesn't have
everything
it.
from the question, so we're getting the exact Young's modulus. But when we use
Number 4 hasn't been to do with Young's modulus. It's like that now. Alright, try number 5, please.
You can't always run away from your mistakes.
No,
Okay,
no, one
but
day
then
they'll
you
catch
have
up
to
with me,
say-
yes, I know, yes, but not today.
Oh, no.
I didn't save it.
What's the unit of K?
Newton per meter. Try number 5, please. 5 solve.
I did 4 and then you deleted it.
Life sucks. Try number 5.
How long?
Yeah, this class for some reason has great trouble when I use how long to mean time.
Yeah, but why are you asking for time?
Why not?
We have to use some other formulas to find something.
I haven't asked any question with time in it yet.
I need to get a key.
Time, yep. 5 solve. Be quiet and do this question, please. Write it down. Lee. Okay, but I would like to see writing as well, please.
We don't need the thickness of the wire, do we?
I'd say you do. I'd say you do. I think you figured it out, Juan, did you? It's a toughie.
Oh, we need it for the mass?
For the math? Need what for the math?
We need MGH, right?
Yeah, I suppose.
And there's an M in MGH.
You have the amp, you have the amp, 200 G.
That's not... Yeah.
Your mouth wanted to say, that's not the math, but your brain said, no, dude, it is.
I have an answer and I didn't need that.
Fine, it's possible that I gave you unnecessary information.
Yeah, it's very possible. Or maybe wrong information even.
That too is possible. Okay, let's have a look here. So, do we know the length of the wire? I think we do. What was it? 2 meters. And then we hang the weight on it, and it's 200 grams, and then the boy pulls it down. He pulls it down 1 centimeter.
Centimeter,
Yeah. And then he releases it, and it will snap back up. Yeah. Right. So when he releases it, it's going to move in what type of motion? Simple harmonic motion. So we know the formula for T is 2 pi root M over K? No. M M over K. So, we know the M, and we know pi. If we knew the K, we'd be finished. We don't know the K. However, we can get the K if we know Young's modulus. Do we know Young's modulus?
Yes.
We do. Still.
The formula and the extension. Why Young's modulus?
You need to know it.
He knows the mass. Oh yeah, the boy is calling it, right. Young's modulus.
Continue with that. So, you know that Young's modulus is F over A extension.
You use the same extension.
No, please. Give me a break here. Extension over natural length. Now, are we okay so far? We agree this formula is true. Yes. Now, you know from Mr. Hook, F equals Kx with a minus, but we won't worry about that. So what does F over X equal? Okay, so we put that in there.
No,
we
no, what Lee was saying was right.
No, listen to me. Listen to us. So we have Young's modulus is K, 1 over A, 1 over L. So Young's modulus is KL over A. So K is Young's modulus A over L. If I put that back in here, I get T equals 2 pi root ML over YA. So now I have a formula that uses all the things I've given. But that's the time to go up and back down. We just want the time to go up. I didn't get it, perfect. So the T is half of this. Pi root ML over YA. Now, let's hit that in on the calculator. What is the mass?
0.2.
What is the length?
2.
What is the Young's modulus for this material? What is it?
5 times 10
The Young's modulus.
100 times 10 to the power 9.
And the area is pi r squared. And what's the r? What's the r?
It's 1 millimeter.
Is it 1 millimeter? Yeah. So it's 0.001 divided by 2. So 0.5. So that's the time.
Okay, go back.
1.6 milliseconds. Wait a second.
Divide by 2.
I already took out the 2. Yeah. Yes, he asked me that and I said I will. Just give me a moment. They need to write this down, okay? Not everybody can do it here. What?
1 millimeter.
Tick. Is it? No. Yes. No.
If it's 1 millimeter thick, then 0.005 millimeters.
Hang on, I'll fix this now. 1 times 10 to the minus 3 divided by 2. Same answer. I was right. I know, it's unbelievable. I was right. Okay. Now, you wanted a question here. So do you realize it was not important to know how far the boy pulled it down? And I talked about this twice before, about for the pendulum, it's not important how far you pull it out when you release, nor for the spring, it's not important how far you pull it down and release. The time is the same. So this 1 centimeter was misleading or redundant information, not necessary information. You get this in the exam sometimes, where you have a question and you feel like you should use this number because they gave you this number, but you don't. Sorry, wrong, you need to write this down. Yes, that's your question.
And then,
Yeah.
you have the steel wire,
Yeah.
and then you put the mass on.
Yeah.
It will extend.
Yeah.
That is the force. The mass times gravity is the force.
Yeah.
Okay. But the boy is pulling it.
Yeah.
So there is more force than just the weight of the mass.
Correct, but when he releases it, that force is gone. That pulling force was only to cause an extension past its equilibrium to disturb it so it can go in simple harmonic motion. That force no longer factors in as soon as it's in motion. Only the gravity and the force of hook is still in play. You know deep down that's true. Yes?
Yeah, okay, okay.
The calculator,
Is there pi into times pi?
there's my pi.
I removed the two because in
I already removed the 2. Oh!
Yeah.
Yeah, 5 milliseconds. Whoops. How embarrassing for me. Oh well, at least I have carpet. 5.0 milliseconds. Thanks, Wong. You see, Wong gives me helpful comments. Yeah. Would a Tesco granola bar be okay? Yes, okay. Tesco granola bars for everyone. Yes? Why did I delete 2? Because it's time to go from here to here. But this time is to go from up to down. Yeah, exactly, a full oscillation, yeah. So that's why I deleted the 2.
Can you make a business class earlier tomorrow? Or is that? Yeah.
What time is it at?
So, we have 3 hours, right?
2. And then you go home afterwards?
Yeah, I'm traveling tomorrow.
I could try, but the problem is, I don't know if there's a staff meeting tomorrow at 1 o'clock, because we usually have meetings on Friday at 1. So, I couldn't say I could start earlier, because I could be sitting in the middle of a meeting. So I would love to, but I can't promise it, because I just don't know how long the meeting will be, so I'm afraid it'll have to be 2. So you just have to suck it up.
Yeah, can you make it earlier?
I could if there was a room free, but the problem last week was there wasn't a room free.
I don't know. You were
Yeah.
tired last week.
That was true, but then I also learned afterwards that Dennis was using that that room for ICT, the exam prep room.
But I think this week he's not using it because everyone doesn't have.
Are you sure?
Yes, so
You could surprise us.
Because he sent us an email last week. He said that he would contact some people for one things.
Right, I'll tell you what. If the room is free at 12, I'll go by at 12. I can see you there. If you see a class in there, then turn around and leave, because obviously the class isn't going to be there. So if you want, you can go to that.
11? Yeah,
They want.
at 11 or
Yeah, go to that room at 12. If it's empty, we'll do the class then, and you can finish earlier. If it's not, you'll have to wait till 2. That's the best I can do. I'll check if you're there at 12. If you're not there, it means you found out that you can't use the room, I guess, or something. I don't know. The room you normally use at 12.
CWA.
Yeah.
No.
The ICT